Okay, and the zeros of a function f of x are the values of x that make the value of f of x 0, just like we set quadratic equations equal to 0 to find the zeros of a quadratic. We can do the same thing, but we've got to get two answers like we do for the quadratic on the absolute value, but we don't have that squared term. So that comes from those two different equations. So on this graph where x is equal to -3 and +3, that's where the function equals 0. Well, this is the equation because notice that the vertex has been moved down 3 units. That's where that transformation of the minus k on the end. Well, how do we get that? Well, it comes from using this function or these two piecewise functions together. So when we're going to use this function f of x when x is greater than or equal to 0. So when x is greater than or equal to 0, we're going to use this function, and when x is less than or equal to 0, so I guess really we could have a separate one in here, but I'll put it when it's equal to 0. We'll use that one at the top. So so these would be the parts of the or the pieces of the piecewise function. Sounds strange to say it that way, that we would be using for this graph. So excuse me, guys. You can see here that when I put in a 3, out comes a 3. When I put in a -3, out comes the opposite of a -3. The opposite of a -3, of course, would be +3. So these definitions you need to put in your notes. So you're going to want to pause this video and write down these definitions. And I am not going to read them for you so that you can write them down yourself and read through them. The only thing I would say is make sure that you are noticing we're getting a little bit more precise in the definitions about by using actually discussing a translation, a reflection, and a dilation, because we're going to get to a lot of this stuff. We're going to get into this a lot more in the last couple of units. So so pause, copy down those definitions, and after that, you could go forward. So here are all of the same rules. Here's that your parent function, of course, will be y equals y equals the absolute value of x minus h, and I'll close the brackets here in a minute, plus k, and I want the parent function, and I'm typing up the general form. So this is the parent function, is just this one here. Let's see, and I'll change the color on that so it matches. So here's your parent function, y equals the absolute value of x, and then of course there are all of the same transformations that we've used in every other function that we've talked about. Reflect across the x-axis gives us the negative here. The A is that vertical stretch or vertical compression. There's another word that we've used shrink for. Compression, of course, is the same as shrink here. You have the horizontal translation, the opposite of x, and your vertical translation. And remember again, the HK is going to be your vertex. So, for example, identify these transformations. So what you need to do is always first make sure, because as the further along we go and the more functions you have, the more you have to take a look at making sure that you're aware of which of the parent functions you're using. So you're going to take this parent function for the absolute value graph, and you are going to vertically stretch by a factor of 3, and then you are going to shift it 2 units to the left and 3 units down. So vertical stretch by a factor of 3 and shift left 2 and down 3 units. All right, so that's probably a little bit big for the space it needs to fit into. So, so that's the first one. Now the second one, and you'll have some just like this on your homework. This one here is just going to be, we can get away from the words shift now and use the translation. So we could say that this graph has been translated right 1 unit and up 2 units. This one now, we could still go with the idea of being vertically stretched. So vertical stretch of, or vertical stretch by a factor of 2 and translated 3 units to the left and 1 unit down. And the last one, notice that in the front of this one is you've got a negative as well as this 1/3. So this one is going to be a vertical compression or shrink by a factor of 1/3, reflected, and we have talked about this, reflected across the x-axis and translated. That's out of the way so I can, maybe it'll stay here. Okay, and translated, make sure we can see all of this, 2 units to the right, I guess it's a -2, and 1 unit up. So really nothing new here with these translations.